So we're going to get started with a new core data project, and it's relatively simple. We're going to follow the same process. I'm going to do this in SwiftUI just because how it ties into core data is actually a little bit simpler, but the same basic ideas, and I can send you some tutorials if you need it, the same basic ideas will apply to storyboard-based projects. And again, because we now know how to integrate storyboard-based projects with SwiftUI-based projects, it's entirely possible to kind of mix and match these things. So how I'm going to get started is I'm going to create a new project just by going File, New. I'm going to bring this over to the recording. I'm going to make a single view app on iOS. I'm going to give it a name. Now what I'm going to do is make a little app that lets me keep track of important dates that are coming up. And I might do something with this later, like allow me to count down to certain dates and that sort of thing. But for now, all we're going to do is create a core data table that will record some basic information into it, like what the name of the date is. And then in the future, I can add things like the actual date range of the date, like the start date and the end date of the important thing. So if I want to count down to spring break, or then once I'm in spring break, count down to how many more days left I have until the end of spring break. This is assuming a spring break in the future. Then I could do that with this app. So I'm going to go ahead and create it. I'm going to call it Big Picture. So this is a SwiftUI core data project that I'm going to demo to you, and I'm going to call it Big Picture. And again, as usual, these files will be up on Canvas if you need them. I'm going to make sure that SwiftUI is selected as my user interface, and then right here, this is crucial, I'm going to make sure that I check both use core data and use CloudKit. We're not going to get into CloudKit today, but you want to include this so that moving forward you have the option. CloudKit allows you to sync the core data record that you have on the individual user's device out into the internet. And this is what's super cool about core data over user defaults. User defaults lets us persist data from session to session to session, so that if the user kills the app or what have you, then it just goes away. However, then it sustains. So if the app stays on the user's device, the user defaults settings are still there. However, if the user deletes the app, then user defaults goes away. And we've used that for our own advantage to do things like if you program something wrong, you just need to wipe out user defaults and start from scratch. That's what you can do. However, and by default, core data will do the same. Once it's saved to the user's device, it'll persist forever until they delete it. If they delete it, then the core data record goes away with it as well. However, if we use CloudKit, then we can sync the core data up to the user's iCloud account, and then it's backed up again. So it's almost as if, before we were using user defaults, data just persisted as long as you were running the app. Then once we added user defaults, then data will persist as long as the app is installed. And now with CloudKit, we can persist the data as long as forever, because the data is now synced out into the internet. So we're going to keep CloudKit even though we're not going to use it quite yet. Hit next, and let's get to it. Cool. Now the second that I turn on CloudKit, I get this right here. And this is a very long name for a project file, so it's hard to see. But it's always going to end with XC data model ID. What this is the actual database itself. Well, again, technically core data isn't a database. You get the basic idea. So if I click on this right here, this allows me to see into the database. And in core data parlance, an entity is what we call tables. So you can see here, I have this entity button, and I can click it and create essentially a new table inside of my core data record. And so what I'm going to do is create one that's called important dates, because that's what I'm keeping track of with my Big Picture app. So double click on it and give it a name. And now ultimately, important dates is going to have a lot of different kinds of things inside of it. And each one of those tables, again, this isn't entities aren't completely tables, but it's basic idea. If you're familiar with databases, it's a nice little analog. The database is a collection of tables in the same way that my XC data model or core data is a collection of entities. And just in the same way that tables have rows, just like in Excel spreadsheets, and then they have columns. The rows are records and the columns are different attributes. So the vertical part, the rows might be different employees, and then the column part across might be like first name, last name, etc., etc., etc. In the same way, entities are tables, and they have not rows but attributes, or not columns but attributes. And so here I'm going to give an attribute to important dates, and they can have an infinite number of attributes, but I'm going to say I want to have one called name. So this is what you would name the date, and the date is a string. And so the date is the name of this date is a string. So you might call this date in spring break, for instance. And then I'm not going to use it, but I'm going to go ahead and create it and say I might have, well, I won't create it, but I might hit this and say like I'm going to have a start date and an end date for that important date. So your start of spring break and your end of spring break, for instance, or the day of your birthday and it starts at midnight and ends at 11:59 p.m. Those kinds of things, or holidays or what have you, would be different types of attributes on a single record. All right, so I have important dates all set up. That's good enough for me. Again, this could be super complex, and I can have a lot of things, and I can create relationships between different entities, which we talked about in the database lecture about creating relationships between different tables. We're not going to get into that right now. Just know all this is entirely possible and pretty cool. So what I'm going to do now is go into my content view, so just my Swift file. And I'm going to not really use the automatic previewing because pretty soon we're going to start doing stuff that will glitch that out. But I have just normal hello world stuff that comes in with my SwiftUI. And what we're going to do first is allow this SwiftUI file to also do stuff using core data. So not just right here at the top, instead of just importing all the SwiftUI superpowers, I'm also going to import the core data superpowers. And this allows this page to also access core data. And how we're going to access that core data is through what we call an environmental variable. And so this is similar to how in core data we had those state variables. We're also going to have environment variables. So this allows us to bring in data out of the core data repository and then use it throughout my file. And it's going to say, well, okay, what kind of data, what kind of file do you want to, or what kind of variable do you want to create here in the environment, in the entire page? And I'm going to do what Xcode or Swift calls manage object context. Manage objects are just what they sound like. They're objects that are managed. And that's just generic parlance to refer to core data. So we're going to get into how do we go ahead and get the core data and all that kind of stuff and sync all these things up. But the important thing, and if you don't totally get this, just copy paste. That's what everybody does. But the basic idea is that I'm going to create a connection to the database and manage it. And this is then, this environmental variable is going to be saved into the name, remember name value pairs, managed object context. And so now I can access my core data repository, and whenever I access that core data repository, it's going to be called managed object context. That's the name of its variable name. You can see that I gave it the same variable name as here. You can name this whatever you want, but I personally like to use that just so that I don't go totally insane when I keep track of these things. I'm not creating multiple database connections and all that kind of stuff, or core data connections, so I might as well name it how I want to name it. And then I'm going to just copy and paste some code because it is lengthy and walk you through what it is. Then what I need, so I've made my connection to my managed object, and then what I need to do is make it so that I can send requests to it. Now in normal code type of things, we would call this a query. Inside of Swift, we call this a fetch request. And so this is requesting some information out of my important dates. Okay, let's walk through it. So a fetch request is going to go into the entity important dates. Remember, that's this right here. And it's going to get an entity out of it. An entity is just it's going to get out of it some of this stuff, or some of this stuff rather. Okay, so it's going to go in and go into my core data. It's going to start messing around with some things inside of here. And then it's going to sort it because you have to sort it. And so, this data could be thousands of records long, and you might want to sort on employee name or sort employee last name or whatever. What I'm going to do is sort on the important date's name. So they're going to come back in alphabetical order. And they're going to come back true, ascending true, which means it's going to start with A and go to Z. If I wanted to flippy flop that, I can. And then it's going to take that request and save it into dates. And it's going to be a collection of important dates. So just know that from now on, dates refers to every single date that's inside my important dates core data repository. And so dates just means every single one. So I might have 1,000 of them. I might have 10 of them. They're all inside of there. Okay. So far we actually haven't done jack squat. We haven't done anything. So we need to go ahead and I'll fix that in a second. We haven't done jack squat. We need to fix that. We need to make it so that we can actually do something with this record, with these fetches and all these records and all that kind of stuff. And so what I'm going to do is scroll down here into the body. And instead of saying hello world, I'm going to create a list. And my list is going to be very simple. It's going to be a collection of all of the dates that are currently saved in the database. Now at this point, there's nothing saved in the database. We don't have anything in there. But and we'll show you how to populate the database in a second. But at this point, we're just going to retrieve everything and put them all as a list. Okay, so I'm going to go ahead and do that. Again, I'm going to grab some code. And I'll walk you through it. So what this is going to do is create a list. And the list is a list just like every other list. Like if I wanted to have Pikachus as a list, I could have Pikachus as a list. Or Pokemon as a list. But for this, what this is going to do is going to go through every single one of those dates that we retrieved and cycle through each one. So for each, it's going to go through each one of those dates. And it's going to it's going to grab that date and run this on it. So each one of those dates, it's going to go through and generate a text object. And it's going to fill it with name, colon, and then whatever the date.name was. So all the dates, when it goes through each one, they're going to be named date. The individual one is going to be called date. And then it's going to go through that date and look into it and pull out its name. Now, what is the date.name? It's this. Each record, this is dates. The individual one has a name. So it's going to get the name out of that date record. And if it can't find it, in other words, if there's a problem with this query, then it's going to put in the word unknown. And then I've added this here too. I'm going to delete this for now. But this is how we can make it so that you can delete records. So there we go. We should be able to just cycle through and generate a list of every single record that's in our database. I got some stop signs, so I'm a little bit worried about if I hit play here, what's going to happen. But I'll fix that if we run into it. Let's figure that out. All right, really stupid error message, or really stupid mistake on my part. I just typed in the word environment incorrectly. Sorry about that. That was an easy solution. Okay. All right, so this is just work. Let's go ahead and run it. We still have a stop sign. That concerns me. It's not managed object context, managed object context. Sorry about that. All right, and now we should work. Okay, great. Everything's working. So without some typos, we're good to go. All right, so we have our list of stuff. Well, list of stuff is pretty worthless unless you actually, have some stuff. So what I'm going to do is inside of this view, I'm not just going to have a list. Right above the list, I'm going to have a button. So to do that, I need to tie these two things together. So I'm going to put in a VStack that includes the list. but it's also going to include a button. And it's a standard issue button. It does all the things that a button normally does. It has an action, and then after the action it has some text that will be what the label of the button is. And so this button at first is going to do nothing. It's just going to have the text, add example data. Doesn't like something to do with my VStack. Oh, it doesn't like how these are included. Okay, hold on. I got to wrap my button inside of something, so I'll put my button inside of a section. And let's check it out. So I have an add example data button right here, and this will populate this data, but we need to make it populate this list. So to do that, that's inside of the action. You can ignore a lot of these error messages. What's happening is trying to generate that preview, and like I said, that preview is not going to work with core data very well. So it's important to just try compiling rather than relying on the little preview thing that SwiftUI generates. So what I want to do with this button is create a new date. And then once I've created that new date, slam it, push it into my manage object, which again, managed object is a reference to the core data. And so I'm going to go ahead and create a date. And set that date to I'm saying this date is one of those important dates things that you've already created up there. This. And I want to use the manage object as my definition of this stuff. And so then what I'm going to do is make a name for my date. So I'll say, hey, change the attribute on that date and add a name. And I'll say the important date might be summer. And we'll just make it generic so that this button just always puts in the word summer into my table. And in a second, we'll contextualize it. And then what it's going to do is try to save the managed data. And so I'm going to have it do an action. We haven't talked about do. We don't have a ton of time to talk about do. But do is always paired with catch. And so what do does is execute some code, and if there's an error in the code, it will run catch. And so catch catches the errors. So I might print there's a problem with the core data. And then you as a developer would see that as you're doing stuff. Now for us, this isn't going to be necessary, but Xcode really likes to pair do with catch so that you are doing proper error handling and that kind of stuff. So we're going to now do something, and what we want to do is try something. And again, if the try fails, it runs the catch. What I want to do is go into the self, so into the big document, and I want to do something with manage object context. And with that manage object context, which again is just a stand-in for my core data, I want to save what I have into manage object. Okay, and so now we should be good to go. So every single time I click this, it should say summer. Great. I'm adding records into my core data. And summer will persist. So if I kill this app and I run it again, all those summer records are still there. Now, simply saying that important date summer is coming up is pretty stupid. I want to be able to do multiple dates, right? And I want to be able to delete these suckers. Now, here's what's super cool. To make these things delete is super easy, because delete is actually built into my list, into the code that SwiftUI gives me for list. And so all I need to do is say, hey, for each one of these things that you're generating, also add a navigation bar item. Oh, I'm sorry. I'm not there yet. We'll come back to that. But I don't want to do it there. What I want to do is make it so that I can have an on delete. explain this in a second. But by simply adding this on delete event handler to each list item, I make it so that users can swipe over from the right to the left, and it triggers that little delete symbol, that little red delete button. And then when they tap it, I run the remove dates function. Now, remove dates doesn't exist yet. I got to create it. And so I'm just going to go up here and create a new function called remove dates. And I create functions just like I've always created functions. And when you trigger that delete thing, it is possible to get more, or SwiftUI is concerned that you might be triggering, the user might be triggering more than one delete button at the same time, which I honestly don't see how that can possibly happen, but they've built that into the code, so you got to work with it. So what you're getting when you swipe, when the user swipes over and they hit delete, you're not just getting the index of which one of those things they tapped on, so 0, 1, 2, 3, 4. You're getting a set of indexes, so 0 and 1 and 2 and 3 and 4. If the user hit delete all at the same time magically, and they all got sent to remove dates at the same time. So we have to do some special code to work with index sets instead of an index itself. But what we're going to do now is the same kind of for stuff that we had done down here. Only we're going to do a for list for index in offsets. So what this is doing is saying, go through the entire set of index sets that's been handed to me and go through them one by one. And each time you go through them, make it be equal to the variable index. And so this will just say, allow me to go, okay, they tapped on 0 and 1 and 2 and 3 and 4, and so we need to do each one of those things. And so I'm just going to temporarily create a little variable called date. It is in reference to that giant dates object that I generated up here. And which one of the dates do I want? I want the one that's at the current index. And then go into the managed object context, so go into the core data and delete the one that we're on. And then once it's deleted, we need to save that into managed object exchanger. So save these changes over into the core data, and we're going to do that in the same way that we've done all the other attempt of saving things that we did down here. I'm literally going to just copy and paste this code right here, which is the do, try, catch combination, and say, okay, look, you changed my local copy of dates, and now I want to save that over in core data. And so now, if I run this, I can delete records. Out of that. Now, from a UI UX perspective, this is pretty stupid. Gestures are not discoverable at all. I think your average user would look at this and say, I didn't want 3 copies of summer. I only want 1. How do I delete one of those? And I don't think they're going to figure it out very quickly by just doing this. So instead, I think it's a good practice to have a little edit button magically appear right there. And what's cool is in SwiftUI, that's all easy and automatic. All you have to do is say, look, down here at the bottom, or rather around this entire collection of stuff that I have, I want to create a navigation view. So that's around everything I've done so far. And on that, inside that navigation view, I want every single thing inside that VStack to have an edit button wrapped around it. And so now there's an edit button that will be associated with every single one of those list items. So when I run it, I now have an edit button up here, and if I hit that, I get this type of interface. And what's cool is that when I hit this edit button and it pulls up this delete button is running that code I've already done, the on delete stuff. So it's basically just revealing the gesture, but it's doing so through a more kind of standard navigational element that users will be used to. Okay, cool. So now I have it so that I can create an infinite number of summers, but let's say I wanted to create another date that wasn't called summer. I want a user to be able to type it into that. Well, what's awesome is I'm just going to use the same kind of stuff that we've done before with SwiftUI with text fields. And I'm going to tie the text fields to a state variable so that the variable is persistent inside of this view. And so as you type into the text field, it will be automatically saving into that variable. And then once the user's done typing it in, they'll hit the save button, which I'll reuse the button that we have currently. It just populates summer, and they'll hit that button, and now it will be whatever the user typed in. So right here inside of just a section holds a button. I'm also going to add a text field to the section. And you know what? Rather than just typing it in because I memorize it, let's just use this, which is a nicer, easier way that you probably are more familiar with. See? Heck, we'll type it. And you'll recall that text fields contain two elements. What the label of the text field is supposed to be before the user types into it, so a little grayed out stuff. And then what you want the text to show, or what variable you want that text field to be editing. So I'm going to say this is and then I want to tie it to a variable, which we haven't created yet, but I'll create a variable called, well, it's temporary, so this date name is only going to be around while the user's typing it and when they hit save. So I might just call it temp date name. Now this is going to be an error message because temp date name doesn't exist yet. So I need to create a new state variable, same way that we did state variables with our tip calculator. And by default, it'll be nothing, just a string. And so now whenever they type into the text field, it will edit this variable. And then my button needs to make use of that variable. So rather than just naming it as summer, I'm going to name it whatever the user typed in to that. So whatever the temp date name was, it will populate it. Now that should give me an error. Now, my error reporting is acting a little weird in Xcode today. This is not going to work because temp date name doesn't exist inside of this button. It's way out here in the entire thing because it's a state variable. So I need to say self.temp date name, and that will be good. So now, and I'll get a better, this button is now saving that, but it's going to have it's got a pretty silly name right here, add example data. I'll say something like save. So I'll run it. And now whatever the user types into this text field will be saved as an important date. So maybe summer isn't the only thing that you care about. Maybe you also care about start of fall semester. And of course I misspelled semester, but whatever. That's par for the course today. Hit save. And now start of fall semester has been saved into that. Go away. So I can do things like delete this other summer stuff. And I might not just have start fall semester. I might then after that want to be able to have winter break. And then winter term. And then spring semester. And you can see these things are going in what appears to be a haphazard order. But what's happening is, remember, way back here, I said I want it to be sorted by the name. And so it's putting it in alphabetical order. So there you go. That's the basics of core data. Now right now all I'm doing is saving one attribute into the core data record, the name, but I might have other things like a date with a date picker, the start and end of that semester and all that kind of stuff. And then I can also use this core data stuff in a bunch of different ways. So for instance, I can take this core data, bundle it up and throw it over on an Apple Watch so that I can have my important date show up in an Apple Watch app. Or I might sync this core data up to the user's iCloud account, and then if they download my iPad app, then it will I can populate my core data repository on that local iPad app really easily is make it so that if they make a change in their iPhone app, then it will automatically update inside of their iPad app. Or I might do the same thing with an Apple TV app, or I might do the same thing with a Mac app. By leveraging something as powerful as core data, it enables all this other possibility that normally would be a real pain in the butt for me to sync between all these devices. Apple allows me to do that using their own technology, so I don't have to worry about it. Very, very cool. So there's core data, and I hope this little grab bag is helpful.